What is spanning tree? So I know a lot of people are currently preparing for their CCNA exam. And one topic that seems to give everybody a hard time is spanning tree. And I know the feeling because when I was going for my CCNA 9 years ago, spanning tree gave me problems. But that's why I'm making this video, so we can sit down and we can have a genuine conversation around spanning tree so you won't be lost. So what is spanning tree? Well, first of all, spanning tree is a layer 2 protocol. That means that it operates at layer 2 of the OSI model, layer 2 being the data link layer. And the main goal of spanning tree is to provide a layer 2 loop-free path. So let me kind of draw this out and explain exactly what I mean. So let's just draw some links between these two laptops right here. They're going to connect to these switches. So he connects here. He connects here, and then we're going to interconnect all of our switches together. So he's going to connect here, he's going to connect here, and he's going to connect like this. Now, when we say a layer 2 loop-free path, this is what we mean. Let's say that this laptop sends a frame into the network, so it arrives here. And now this switch has the frame. Ideally, what we would want if the frame is destined to come here is for him to send the frame this way, and then this switch right here sends the frame that way. That's ideally what we would want to see. What we don't want to see is for something like this to happen. This laptop sends the frame here. Now this switch, he's going to send the frame this way. And then this switch, he's still going to send the frame here. But at the same time, this switch is going to send it here. And then this switch is going to send it right back. So essentially what happened is the frame went this way. It circled around and came back. Excuse me. That, my friends, is what we call a loop. At no point should a frame get sent out of this port and then loop around, come back to the switch on this port. That is what we're trying to avoid, and that is why we run spanning tree. Now, if we want to avoid the loop altogether, what we could do is maybe get rid of one of these links. So for example, maybe we get rid of that link. So now, if this PC were to send traffic this way, this switch sends it here, there's no way for it to loop back around because there's no connection right here. So there's no way for the frame to come back that way. But now you've put yourself into a position where you have what's known as a single point of failure. So if traffic was originally going that way, what happens if this link were to fail? Well, what you just did was you just isolated this switch from the other two switches, and you just broke connectivity between those two PCs. So ideally, we want to have redundant links between our switches, because if traffic was flowing this way, going from this switch to this switch, if this link right here were to ever fail, traffic could then route this way and you can still get to this PC. So this one link failing doesn't break connectivity between the two laptops. But when you add this additional link, you do add a situation where traffic can go here and then loop back around and come right back. This is what spanning tree is trying to avoid. So what spanning tree will do is say this: I'm going to block some of the links in the network so you cannot use them. So for example, spanning tree will come and say you cannot use this link. So now if traffic wants to come from this PC and go to this PC, it has to go this way. Now I know you're thinking, well, why would I want to go the long way when I can just go directly to this switch? Well, based on how spanning tree is set up, spanning tree has said you cannot use this link. Now, what if you had a failure, right? And what if this link were to fail. Well, since this link is no longer available, Spanning Tree says, okay, you can be used now. So now traffic can flow this way because this link is no longer usable. So since this link is no longer usable because maybe the cable is bad or maybe the port got unplugged, even with this link being up, there's no way traffic can go this way because this link is down. But the minute this link comes back up, Spanning Tree says, okay, you're good, you're down. So at no point will all of these links be usable at the same time. So there's no way for traffic to come here and loop back around. At the same time, there's no way for traffic to go this way and loop back around. Because one thing I failed to mention, without Spanning Tree, not only can it loop in this direction, but it can also loop in this direction. So you can have a loop going on in both directions. But this is what Spanning Tree is going to prevent by blocking certain links in the network. So let's take a moment and let's explain how does a loop occur. So there's one thing that you learn about at the CCNA level that all switches do. It's called flooding. This is where the switch, when it determines a frame needs to be flooded, he will send the frame out all active ports in a VLAN except the port it came in on. So using our topology here, let's just say that this switch or this PC sends a frame into the network. This switch determines that this frame needs to be flooded. Now let's just say that this port is a member of VLAN 10. So what he's going to do is he's then going to flood this port out any other active port that's also in VLAN 10. So any access port that's in VLAN 10, any trunk port that's tagged for 10. So these links between the switches, let's just say they're trunk ports and they're carrying VLAN 10 traffic. When the switch has determined that this frame needs to be flooded, he sends it here and he sends it here. Okay, now to keep it simple, let's only focus on the frame that goes in this direction. So now this switch gets it. He determines that the frame needs to be flooded. Now, since it's tagged for VLAN 10, since it's coming over the trunk, he knows that this frame needs to be flooded out every active port in VLAN 10. So if this port right here is also in VLAN 10, he sends it here. But then you also got this trunk port that's probably tagged for VLAN 10, so it goes here. And this switch is going to do the same thing. Once it determines the frame needs to be flooded, he sends it this way. And that's how you're going to have your loop. Okay, anytime a frame needs to be flooded, this is what's going to cause the frame to kind of loop around. And like I said, we only looked at it coming in this direction. It's also being looped going the other direction. So you will have this frame being looped in both directions. Now, a frame is only going to get flooded depending upon the type of frame. The main type of frame that's going to get flooded is a broadcast frame. A broadcast frame is when the destination MAC address of the frame is all Fs, similar to what you will see in an ARP request. So let's just say that this laptop down here at 10001, he's trying to send data to this laptop, which is 10002. But of course, he needs to know the MAC address of this laptop, which he doesn't have right now. So he's going to generate the ARP request. And he needs this ARP request to go to everybody that's on the same subnet as him or the same broadcast domain. So since he needs this ARP to go to everybody, he's going to make the destination MAC address all Fs, and he's going to send it into the network. When the switch sees that the destination MAC address is all Fs, this alerts him that the frame needs to be flooded. So going back to our previous example, if he's in VLAN 10 on this port, this frame is going to get flooded out any other active port that's also in VLAN 10. So it's going to get sent out of both of these trunk ports, and it's going to go this way. Now, when this switch gets it, he's going to see that the destination MAC address is all Fs, and then he's going to flood it out the trunk port going this way. Now, this switch right here is going to get the frame as it comes in here. He's going to do the same thing. He's going to send it out the trunk that way. And he's also going to forward it to this PC because this PC right here, this port is going to be in VLAN 10. So I don't know if you can kind of see what's happening, right? So the frame gets up here, it comes in this way, he just sends it here. And the frame that came in here, he's going to send it here, and he sends it here. So I know it's kind of messy, but I want you to see what happened. This PC got 2 copies of the ARP request. So he's getting redundant information. He got the one that came this way, and then the one that looped around this way. So he got 2 copies. I also want you to notice that the one that went this direction is coming right back here, and the one that went in this direction is coming back here. So you got a loop going this way, and you have a loop going this way. I meant to put that in a different color. Going in this direction. So you got 2 loops going on in 2 different directions. Okay, that is with a broadcast frame. Okay, the other type of frame that you can see that could potentially loop, you're not going to see this a lot, but it could potentially cause a loop, is going to be an unknown unicast frame. This is where the destination MAC address belongs to a specific device, but the switch hasn't seen it yet. It hasn't learned that MAC address, so it doesn't know where to send it. So instead of dropping the frame, he floods it. So let's just say this PC here at 10.0.0.1, he's trying to send traffic to this PC at 10.0.0.2. This PC knows that the MAC address that belongs to this IP is MAC address B. So the source MAC address of the frame is going to be A, because this is the PC that's sending it, and the destination MAC address is going to be B. So it's destined, the frame that is, to go to whatever device owns this MAC, and then he sends it off into the network. Now, if for some reason it gets to this switch and this switch has not learned MAC address B, instead of dropping the frame, he will flood it. So again, if he's in VLAN 10, he's going to then flood the frame out every active port that's also in VLAN 10. So it goes this way and it goes this way. And if neither one of these switches have learned that MAC address as well, then they're going to do the same thing. But like I say, this one isn't that common. Typically, you're only going to see this type of frame looping when you have an attacker who's attacking your network and he's flooded the network with these random frames with all of these different MAC addresses where the switch fills up his MAC address table and it can't learn anymore. I'm not going to get into details about that because it's kind of outside of the scope of this one, but you will see traffic being looped if it's an unknown unicast frame. The most common one that's going to cause a problem is broadcast frames when the destination MAC address is all Fs. Now, the reason why this is a problem is because frames, unlike packets, do not have a time to live value. See, let's just say that we have router 1 and we have router 2. If router 1 was to send a packet over to router 2 trying to route it, the time to live value in that packet is going to go down. So even if router 2 turns back and sends it right back to 1, well, now you have a layer 3 loop. Okay, layer 2 loop is when you have a frame loop in between your switches. A layer 3 loop is when you have routers or you have a packet that's being looped between your routers. The key though is with the packet, even though it's looping between these 2 routers, eventually the time to live value is going to get to 0. Once the time to live value in the packet gets to 0, the packet gets dropped. But we don't have that with a frame. With a frame, there is no time to live value in a frame. So there's nothing stopping the frame from doing this forever and just keep looping around. And not only is it looping this way, remember, if I get my other color, it's also looping this way. And there's nothing stopping the frame from doing this forever until you break the loop. Now, what this can do is this can lead to what's known as a broadcast storm. A broadcast storm is where you have all of these different broadcast frames that are just looping around. And it occurs in a very short moment. It's just a burst of broadcast traffic that's just looping around your network. That's a broadcast storm. Broadcast storms are bad because it can lead to network performance issues. So for example, if you have all of these broadcast frames looping in this direction, not only are they looping in this direction, they're looping in this direction. What they're doing is they're eating up at the bandwidth on all of these links. So if you have other devices that are connected to these switches, not only are they competing with each other for bandwidth, they're competing with these broadcast frames that's just looping around. So it's not enough bandwidth for everybody, so your performance is going to suffer. It's also going to cause the CPU on your switches to go to 100% because they have to process all of these frames. See, a switch cannot process frames in hardware. You probably heard of the term Cisco Express Forwarding, or CEF. It allows the switch to process certain packets in hardware, and it doesn't have to consult the CPU in order to do that. It allows the switch to then make decisions quicker because he doesn't have to think about it. Anytime the switch has to do something where he has to think, he has to go to the CPU. Every frame that comes in that switch is going to go to the CPU. So when you have all these frames that the switch has to then process, it can cause your CPU to go to 100%, meaning your switches aren't going to perform like they should because he's too busy, right? If I'm too busy trying to process other things, how am I going to process you? It's going to slow you down. Not only that, you can actually have the switch lock up and just not do anything. You may have to power off the switch. The switch may even reboot itself. So we need to prevent these loops because this is what can occur, and this is what Spanning Tree is designed to do. Remember, if Spanning Tree comes in and he blocks one of these links, let's just say that this link right here were to fail, even if this PC were to send a broadcast frame here, there's no way for that frame to loop back around because Spanning Tree has said this link cannot be used. It can only be used if this link fails or this link fails. That's how Spanning Tree is going to prevent the loop. Now, we got to determine, well, how does Spanning Tree determine that traffic should go in that direction? Or should traffic go in this direction, right? How does Spanning Tree determine what path to take? Well, that's what we talk about in future videos. All I wanted to do in this video is give you a basic foundational understanding of what Spanning Tree is, what's the purpose of it, and how can a loop occur. And in future videos, we can build on top of that and talk about how the Spanning Tree topology is then built. So if you want to see more content just like this one, hit the subscribe button, hit the notification bell so you don't miss out on no content. And I'll see you guys in the next video.